What's up guys, it's Iman Fiaz and today's video is on multiple choice questions, organic analysis. It was question 1 but it was more of year 13 and it was about, what's it called, NMR spectroscopy, all of that, and I have gone through it by myself, I haven't gone through it in class, but I'm still not confident with it. It's a very, very tricky topic, so I didn't include that question since I'm not very confident with it. Question 2, which can be used to distinguish between these two compounds? Well, first thing I can see is that they both are aldehydes. The C double bond O functional group is at the end of a carbon chain, so both aldehydes. So if I use acidified potassium dichromate, that's not going to be any good because they're both going to give the same results. If I use the fingerprint region of infrared spectrum, that is going to be useful because they're going to have slightly different fingerprint regions. Remember, the fingerprint region is the region below 1500 centimeters to power minus 1. The MR value, they're going to have extremely, in high resolution, they're going to have extremely identical MR values. The tolerance region, same with A, it's going to just show the same result, so that's not going to be any useful. Question 3, which compound decolorizes bromine water in the absence of sunlight? In the absence, so without sunlight. Well, definitely, well, think about it. Well, obviously, it's going to be an alkene that can decolorize bromine water. So which one is it going to be? It's definitely not going to be A. That is a halogenal alkane. So we're looking for an alkene. Now, if you look here, 1, 2, 3, 4, 5, 6 carbons in cyclic structure, cyclohexane. Cyclohexane. That does not have any double bonds. And if I look here, what is that? That is benzene. C6H6. And does benzene have double bonds? No, it's more of a hybrid. And in this case, it clearly doesn't. So the answer must be D. Now, why is it D? Because surely that is not an alkene. That does not look like an alkene. Alkenes and general formula CnH2n. Count the number of carbons here. 1, 2, 3, 4. C4. Count the number of hydrogens. 3, 4, 5, 6, 7, 8. It's C4H8. Therefore, it must be an alkene because it has the same exact general formula of an alkene. That was a tricky one. Question 5. 3 regions are added separately to 4 organic compounds. Which row shows a correct observation? Part A. Propanol, sodium hydrocarbonate, effervescence. Propanol, so it's got a hydroxyl group, and well, it shouldn't actually effervesce with that. No, it shouldn't. Acidified potassium dichromate, orange solution turns green. Yes, primary alcohol. Tollens region, no visible change. It's not A. There's no effervescence. Propanal, that's an aldehyde. Aldehyde, sodium, hydrogen, carbonate, no visible change. Yes, exactly. Sodium hydrogen carbonate is used for carboxylic acids, to test for carboxylic acids. Yeah, so that's true. Orange solution turns green with acidified potassium dichromate. It's true, it's an aldehyde. Tolerance region, silver mirror. That's absolutely true. If I look at the ketone, no visible change. Ketones ketones can't be oxidized by tolerance region. There's no visible change. It's not a silver mirror, it's a ketone. And if I look at propanoic acid, silver mirror with tolerance region, I don't think so. So the answer is B. Once you break it down like that, it definitely is a lot easier to attack the question. Question 6, infrared spectrum of organic compound is shown. Which compound produces the spectrum? So I'm obviously not going to care about this region, the fingerprint region, because that's the region below 1500 centimeters to power minus 1. What I'm going to do is obviously go to my datasheet, my periodic table, flip over the datasheet, table A, the infrared absorption data, and I can clearly see there's a peak here, peak here, peak here, what, 1750s? What is it? 1900, 1800, 1700, 1600, 1500, so 1600, 1700, 1720, something like that. And if I look at the infrared absorption data, that is a C double bond O, 1720, yeah. So it's got to have a C double bond O bond. So that already tells me it can't be pentuene, because that's only got carbon-carbon double bond. It can't be ethanol, that's got an OH group. Propanoic acid or butanone. And if I look here, that's clearly at 3000. 3000. CH. It's in the middle of CH and it just, that's the end of OH for acids. So it's gonna be butanone then, not propanoic acid. Question 7, which compound forms a molecular ion with a different precise molecular mass from the other three? Butanone, cyclobutanol, dimethylpropane, methylpropanol. Molecular ion. Molecular ions form when one electron is removed from its mass spectrometer with a different precise molecular mass from the other three. So I think it wants us to just work out the MR of each one. That's what I think it wants me to do. Butanone, obviously, it's going to be a ketone. It's going to be butanone. Butanone. C4H8, and it's obviously got that carbonyl group. So it's going to be that carbonyl group. So literally, it's just going to be C4. Think about it: butanone, methane, ethane, propane, butane. Got a carbonyl group in the middle. You've got your hydrogens 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be C4H80 oxygen. Cyclobutanol, butanol, obviously it's going to be methane, ethane, propane, butane. C4H, what is it going to be? Butanol, C4H9OH. Cyclobutanol, does that change anything, the idea that it's cyclobutanol? Well, cyclobutanol is C4H7OH. Oh yeah, because because of it's got that structure, that cyclic structure, we'll have to minus 2 hydrogens. So C4H7OH, H7OH. Is that the same as part A? Yes, because that hydrogen goes there, C4H8O. Now I'm left with C and D. So you can see it's taken quite a while. Dimethylpropane, methane, ethane, propane, dimethyl, dimethyl. So what does that tell me? Dimethyl. So it's got two methyl groups. Um, so CH3 here, CH3 here, and then obviously fill in the hydrogens. And if you look at that, look what we have: 1, 2, 3, 4, 5. And even if it wasn't, let's say it's 1, 2, 3, 4, the hydrogens 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not going to match up. So therefore the answer is going to be C. And I can work out methylpropanol, methane, ethane, propane, al, so it's aldehyde. It's got a carbonyl functional group at the end of the carbon chain. And then I've got my hydrogens. I've got methyl group. So I've got 1, 2, 3, 4. Actually, no, that's not. No, I've got my methyl group. Wait, what? Methyl group. So 1, 2, 3. 1, 2, 3, 4, 5, 6. Yeah, that's just C. Question 8. Which compound gives us infrared spectrum? 1-bro dash bromobutane. Obviously, I don't care about the fingerprint region, aka the region below less than 1500 centimeters to power minus 1. I care about the rest. So I've got a very short peak here, a peak here. Remember, for the infrared spectrum, the peaks always point downwards. Just a quick review. So I've got one at 1600, 1700, 1740, 30. Let's say 17. Yeah, so that is definitely going to be a C double bond O carbonyl group, and this one is more here, 3000. So obviously I can already eliminate butane, butanol. Now I'm left with butanol, butanoic acid. Well, it's got C double bond O, and this 3000 is an OH for acids. But remember, for carboxylic acid, it's C double bond O OH. So what it's got to be is a C and OH, not just an OH. The answer is C butanol. And question 9, which of these infrared spectra could represent a carboxylic acid? So we don't care about that region. Don't really care about that region. And we don't care about that region. And there's also part D as well. Option D. Don't really care about that region. Fingerprint region below 1500 centimeters to power minus 1. So carboxylic acid, I've got a peak here, actually a very nice peak here, and that peak here is again like 1750, so that's C double bond O. And this peak here is more like a carboxylic acid, so obviously we're looking like C double bond O OH. And that's more like, yeah, that's going to be the answer. Hey. Yep. Okay. And then question 10. Which of the following compounds would form an orange-red precipitate when heated with failing solution? So I've got a nitrile. So this would be methane, ethane, propane. Propane nitrile. Propane nitrile. Yeah, I think it'd be that. Option B, that would be methane, ethane, propane. Is it this carboxylic acid? Don't really need to name them out. It's carboxylic acid. C, that is because if you try to draw it out, CH3, and you've got your C double bond OH, for example. The carbonyl group is at the end of the end of the chain, so that is an aldehyde. Whereas in this case, you can see the CO is in the middle. That is a ketone, and this is a carboxylic acid. Which would form an orange-red precipitate when heated with failing solution? Failing solution doesn't react with ketones. It's not going to react with propane nitrile. Nitrile, there's another solution to test for that. The observation. Carboxylic acid or aldehyde is obviously going to be an aldehyde. And I could immediately target this question now because all I know, I'm looking for an aldehyde. There we go. That's a C double bond OH at the end of the carbonyl functional group. Perfect. At the end of the carbon chain. Perfect. And that is the end of the multiple choice questions.